Okay, so what we have here is a brake lathe. Now this machine cuts rotors, hub type and floating type. It can do drums and it can do flywheels. Now right now I have my adapters out for doing hub type that wind up fitting inside a rotor where our race is. It's going to ride on the race. Now I have a bunch of other adapters down here for doing floating type. We have our on and off switch. We have a lever here that makes this whole table, when I makes it that if I pull it here, I can now turn this handle and move my table in and out. When I put it to this direction, there's a motor inside that makes the whole table move, which is going to control our carbide bits that do the cutting. This adapter is for doing flywheels and drums, and we have a switch over here that if we're doing rotors, we want it on rotors. If we're doing drums, we want it on drum. And then we have another activation switch that I can make this handle move in case I'm doing drums. But all we're worried about today is for doing rotors. So what I'm going to do is set up my machine. So I already got my adapter picked out that's going to fit into the race. So inside our hub types, our bearings and races, which we inspect for any damage, and these were good. And then I'm going to use this adapter so we can get this thing to ride on this thing, what we call true. That it's not going to have any wobbles in it. There might be wobbles in it because it could be warped. And warped rotors cause shaky brakes. Also can cause brake squeaks. You'll feel a vibration in your brake pedal. But anytime you do a brake job, you should have a really good surface on your rotor drum or on your flywheel if you're having a clutch. You want it free of cracks, any hardening, any foreign material that might have gotten in there from the pad. Pad do transfer some defects into the face, and we want to have our new brake pads break into our rotors properly. So what I'm doing now is I am adjusting my bits. I'm going to knock them out a little bit so they're not going to hit my rotor when I start turning my handle to get it to come in. So now they look wide enough. I'm going to start drawing my bits in to make sure that I'm not going to ram them into the rotor. And now I'm going to start my machine up. So now I have my rotor turning. I'm going to turn this dial until that bit just starts to touch the rotor. Alright, so it's just starting to cut. Now I'm going to do the same thing here. I'm going to twist this dial until that bit just starts touching. Now I'm going to come here and I'm going to turn this, which is going to move those bits. Now what I want to do is bring the bits all the way in there. It's going to cut the whole surface that the brake pad is going to ride on. Alright. Now it's going to be very hard to see. These numbers are kind of worn out, but I'm going to bring it to the number 0. Which is right there where this black spot is. There is a number 5, and that's going to represent 5 thousandths. 0.005. Now I'm going to do the same thing here. I'm going to turn this dial here until I have my 0 showing. I'm at 0. And now I'm going to turn this whole dial here to 5 thousandths. I'm going to lock these in place. I'm going to set the camera right here so we get time lapse it cutting. I hit this handle over here, by the way. This handle here activates this wheel which has a motor inside. It's going to pull out at a certain speed, which is going to move these cutting bits. Okay, so before we cut this rotor, it was 0.970. So let's see how much we wound up taking off. So I got 0.952, so we took off 18. So it took more off than the dials actually said. So you can't go by what the dials say on the machine, you have to measure before and after. So we took off 0.018. That's how much we removed. That we have 0.951. Now what I would do now is I'm going to have to Google it and see what the minimum thickness this rotor can be to be put back on the car.